All right. Okay. Okay.
That's fine. So what I'm going to do is I'm going to stop my video and then start sharing my software so that it will not interrupt. Is that okay?
Okay. That's fine.
Is it visible now?
Not yet. Okay. Now it's visible, sir.
Yeah, good. Thank you.
Okay.
Good. As I promised, that we can go ahead with the learning some software. This particular software is known as an orange. We can use light-weighted data sets on this and then try to do machine learning techniques. The installation is free, then you can download the software from the source. And this software got, say, various panels in the left-hand side. One is referred as a data panel. And then you can have a visualize panel, model, evaluate. And then you can also see unsupervised learning techniques. There are plenty of techniques that are available. You can do image analytics, time series data analytics, text mining. You can do some simple survival analysis, networks, and you can do some data mining and association rules and so many other things. What we're going to do now is actually that to try to do using one of my available data to model and then see that whether we can do some sort of an supervised and unsupervised learning techniques. Once we learn that how to connect and do the things, that's more than sufficient that you can do any analysis possibly. From your left panel, you can draw the widget. The first one is referred as a file, which I've already drawn here. And I have selected my data set. This data set is referred as a brand equity data set, which predominantly the original data set was something different. I'll show you the original data set first. The original data set is a Likert scale data set. We have 3 items for perceived quality, and then 5 items for brand loyalty, and 3 items for brand awareness, 3 items for overall brand equity, and then 4 items for brand association. These individual items are grouped together. Then I have my next sheet from the Excel sheet, which is aggregated data. In the aggregated data, I aggregated, it means that I found an average of every items put together in the particular classification. PQ, BL, so perceived quality, brand loyalty, brand awareness, brand association, overall brand equity. And then the CLC is more towards a classification for NPS, it is Net Promoter Score. And this is taken as a categorical variable, so which has a value 0 and 1. It's automatically informing that this particular column got a categorical classification with a binary number 0 and 1. And each and every variable considered here are listed as a feature. Actually, you can change it to target if you wish, but as of now, I'm not doing anything. Let everything be a features. Once you pull the data inside to the frame, the next one is we are expected to view the data. To view the data, you can use a table, data table. When you double click the data table, you don't find anything here because as of now, nothing is fed inside. What you can do is you can connect the given file to the data table. Once this is done, then it means that what are the data which you have chosen here, which fed into the data table, then you can see the data very clearly, what all the data is available. You can see here some sort of an additional information. You have 100 samples, so 100 instances are there. There are 6 features are listed, so you can see that 1, 2, 3, 4, 5, and 6 features are listed. And I did not declare any target variable, so the target variable is no. And there is no metadata is available for this, so there's no metadata. And time being, we can use this data set. So the data is available for the manipulation. What we can think of is, first of all, we may be interested to see this data. So we can start thinking of visualizing the data. So I'm interested to bring in a box plot to see that whether I can see what is available inside. So my duty is to just go and connect the data set from the table to the box plot. It says that select data to the data, but I'm interested on the entire data set. So I can double click this particular line and then change it to data to data. In that way, you can say that data table is moved on to the box plot with the data to data. It means that the entire data is moving, not the selected data. Say OK. Then you can double click here. You can obviously see your box plot here. Since you're holding a classification variable, it always, you can see that you can classify the variable into 2 because it has a 0 and 1 value. 1 is for the net promoters and the 0 is for non-net promoters or highly loyal customer and non-loyal customer. You can see that how the classification is taking place. If you're not interested, you don't need to do just leave it. You will be getting your values done. So I'm not here to explain you what is a box plot. You know what is box plot is all about. I'm only showing that what are the ways you can do this kind of quick graphical analysis. And you can say that if you see that your classification variable, then you can see the number of variables are here about 55 plus variable or 0 classification, other one is in 1 classification. Yeah, plenty of diagrams are available. You can make use of any diagram to do that one. You can see that you can think of a next diagram here. Again, I'm saying that it's selected data. You can make sure that you are only doing data to data modeling. Say, okay. Then you can think of seeing that one in a violin plot. You can play around with lots of options that are available with the violin plot. You can also change to horizontal to vertical plots. And also you can change the density function to a linear or kernel density or a normal. Accordingly, you can see your violin plot. Again, you can classify them into 2 pieces because you're having a classification variable in your hand that will help you to classify them into 2 groups or multiple groups. Like this, we can use any number of given diagram, but we are also interested on identifying is there any scatter plots are there? Is there any relation taking place between these 2 variables? You can connect it. Again, the same procedure. Double click. You can say the data to data. Say OK. Now you can see that the plenty of way to visualize this one. I'm saying the relation between the perceived quality with overall brand equity. And you can also color code with your classification. So here's a color code can be given based on your classification. Also overall brand equity or anything, you can use it. You can use brand loyalty. You can use brand awareness. You can find a correlation between the scatter plot between brand association and overall brand equity. This also provides some more additional information like the contour plots like regions where it is concentrating on. You can also draw the grid lines and so on. And also you can plot a regression line for that one. These are the individual class level regression, and this is an overall regression, which can be classified into select to get only the overall regression part. You can see that the R value is 0.4, so positively correlated, not very high. Let me keep that one in a bit above so that I can go ahead and doing the other analysis. As of now, we have seen that one here. I did not declare any feature variables. The target variables here, everything is a feature. In order to run a supervised learning, I told you that we need to have one target variable. In order to get that one, we are expected to go and select column. The select columns, you can see that are plain information. Here, the variables are ignored variables. You can define the feature variable and the target variable. You can do so by connecting the data table to the selected column. Again, the default is going to be selected data to a data. We can change that one to data and say okay. Then you'll get all the tables are available. Now, these are the 4 features we have, and my interest is, can I predict my overall brand equity based on perceived quality, brand loyalty, brand awareness, and brand association? So I would like to keep these 4 as a features under the features box, and the OB as an target variable. With this, we have decided to set the target variable. You can close this one. Now we can straight away model it. Let me model straight away with the first point. We need to have the test score. With the test score can be identified from the model evaluation. You can see them from the model evaluation from the left panel. You can bring the test score like this. Or you can right away right click and then select it from here. Either of the way I can do it. So I've selected the test score. And I'm saying that send the data to evaluation panel. That's fine. But I did not declare the model here. I wish to declare the model. You can go to the model. Let's say that to start with, I'm interested on the linear regression model. I can bring the linear regression model here. And then connect that into the test model. The test model is not working. Well, I will tell you that what exactly how it's going to work. The time being, we'll see that one. When you see here whether you need an intercept, we need an unchecking intercept is required. And I stated that there are so many procedures are required to run the model. In the regularization part, which we have seen in the theoretical side, we can run a rigid regression model. We can run a lasso regression model where we can classify them. What is the elasticity net mixing? Elasticity net regression you can run. There are so many plenty of regression you can run based on the requirement, whatever the method which you are wish to follow. All these are come under the machine learning algorithm models. here, when you're going for a test and score, we are saying that the data is transferred from test data to test data. Sometimes we are interested to transfer the data to test data too. In this case, you will be expecting to get 2 lines. Again, you will not be having any results. But here what happens is, you can always get the test data and the trained data set. You can test always what is the percentage is defined. But here at present, I'm not given any percentage classification because I did not brought such a widgets inside. Without bringing the widgets, I'm doing it. So there's no meaning in splitting the data into 2 pieces because I'm not giving any classification level, but you can also declare the classification level at this stage to what is the level you want, maybe a 70-30 percentage if the random sampling is required. Let's not do that one time being. Let me remove all the widgets from here. Then it comes to the model. Your first modeling is referred as an random forest regression, which is a supervised learning regression. In this regression, what happens is we classify them every problem into a small 3 problems, and then multiple trees are estimated. Using a random forest method, we can say that our mean square error is 0.5, our root mean and square value is 0.707, and our absolute error is, mean absolute error is 0.462, and you are having a 70% of the predicting power. But our interest is to see that what will be the prediction. From here, you can drag a line, and then you can directly choose the prediction. I would like to see the predicted variables. Once this is done, you can directly see that one. This is your original OBE, and then the random forest prediction. The original OBE is 7, and then random forest is nearly predicting that particular value. You can see the values here. So the predictions are pretty good. You can also see that whether the prediction, how the prediction is going. From here, you can think of drawing a scatter plot from the predicted data. Then you can say that you are interested to identify your original Y, which is OBE, with your random forest values. This is what the prediction is taking place, if you want to see that one in a visually. But as of now, what we did is we are just using only one supervised learning. We can also think of using other supervised learning. Let's say that we remove this one. Then I can say that I would like to have a support vector mission, which is another type of supervised learning, which is done. Then you can say that support vector mission is doing an 50% variation could be explained based on support vector mission. Now you say that, no, I would like to compare support vector mission results with random forest results. In that case, what you can think of doing is bringing a random forest from the panel. You can place it. Then you can see that, okay, you are interested to connect that one to one. Test go. So in this way, what happened? You'll be getting both the scores. You can see that one random forest is outperforming support vector mission algorithm. You can see that the values are far better than the support vector mission algorithm. It's not only to use a tool, you can bring any number of available machine learning techniques. Like for example, you can bring neural networks, and then you can see that how the neural network is performing when compared to other two defined methods. It's a very small number, that's why it's very quickly happening. If you are using a large data set, probably it's going to give a trouble. This software is more useful for a smaller number of data. And you can see that one, even neural network is not doing well for the given data set. The random forest is still outperforming. Usually people say that neural network can outperform any other algorithm with random forest and SVM. But in this particular case, this is what happening. Still the neural network is 60%, so I can easily, if at all I'm interested to rank them based on R-square values, then I can say that random forest is really doing well. I can give the first rank, then goes to the neural network, then goes to SVM. There are some tuning parameters are available where you can tune it. As of now, I'm using an 100, 10, 100 as my neural network procedure number, the number of hidden layers, and then input and output layers. You can use 4 types of activation functions here. One is ReLU, tanh, logistics, and identify. ReLU is far better. And also you can use which solver you wish to solve. I have shown already in my theoretical slide, whether you are interested in stochastic gradient approach or LPFG or Adams itself. Excuse me. You can use LGD, stochastic gradient method. So every time you choose, your model will run once again and then see that is there an improvement taking place. If I use a stochastic gradient, the results are not doing well, it's too worst. And probably you can change that one to the best one, which was Adams. Then you can see that the performance is better. Most of the time it's a trial and error, and we also do so many other hyperparametric tuning in advanced level of machine learning, wherein we can tune it properly and then we can get the best out of models. Fine. If at all we are interested to bring, let's say that naive Bayes. I can also bring a naive Bayes again connected to the test problem. So that test problem naive Bayes is not taking into account. Let's not, because it's looking for a classification. Let's remove that one. As of now, I'm not using any split procedures. I'm just directly taking a data and then running 100%. But this is not a good way to do it. We are expected to only sample, say that 70 to 80% from the original data. If at all we are interested to do, then we are expected to bring a data sampler. So you can see that a data sampler should be available here. I cannot find it. Where it is? Here it is. You can bring it and then you can put it in between. This is one way to do it. So automatically it connects the line. But I did not select anything here. Let's go and see the results. The results are given. So the data sampler, it's doing all 50% or 58% explanation. Let's go here and then choose here. Let's say that I want 80% split. It means that use 80% of data to model it and 20% of data to test it. In such case, what we can think of is, after choosing this one, we are expected to go here and test it. What's the test on the data? The train on the data. But the problem is, test on the test data is not going to show here. The reason behind this, if you seriously watch here, we have sample data to the data. It means that whatever the data which you have sampled, you are sending to the data for the modeling, which is 80% data is going here. The rest of the remaining data, you are expected to send it for the test. The moment you did this one, you will be having 2 lines from the data sampler to the test score. One is the original 80% of data is going inside for the modeling purpose. The rest remaining 20% is going for the test purpose. In that case, you can see that you will get the data here. Test on test data set. And this is test on the training data set. If you see that one test on the training data set, which is 80% of data is coming inside, in that case, you can see that really the models are performing very well. And then it's going to the beyond the limits of points, like explanatory power is higher, like a 0.96. It means a 96% of explanatory power for the neural network, which is obviously outperforming with all the other 2 models. But whereas when it comes to the test data set, it means that you are using the 20% of the given data to model it. In that case, the explanatory power is only 44% for the neural network, though it's outperforming when compared to random forest and SVM. You can see here the explanatory power is not so high as when it's doing a test on the training data. It is very obvious that because test on the training data, we are use the 80% of the data to model it, and again we are testing those 80% of data. Obviously, you can see that the higher explanatory power for the given data. But whereas the 20% of data which is not shown to the model during the model preparation, and we are trying to use those 20% of data to model it. In such case, the explanatory power is only 44% for the neural network, whereas 29% for random forest and 25% for SVM. You can also think of doing other modeling approaches. Other one is referred as cross-validation. In the cross-validation, what we usually do, we split the data into, let's say, for example, here, 5 subsets. And then we run the model 5 times. Like every one time, once one piece of set is kept as a test set, unused data set, which is a test set, and all the 4 is kept as a training set. We can do it for multiple times to get then cross-validation. Cross-validation is one of the powerful procedure when compared to a split procedure. If you use a cross-validation procedure, so still we are getting our solutions done, and you can do a cross-validation here. The model is running. Now you can see that when using pure cross-validation procedure, then you can think of getting a value. Now this time the neural network is not performing well, whereas a random forest is outperforming. As I stated that it's always good to go ahead with using possible procedures, possible supervised learning, so as to get the best model to fit inside. And also your model comparison could be done with any of the given statistics. We can call as the specific statistics to go for. You are interested in identifying based on the coefficient of determinants, or you are interested to identify based on the error. So you can go ahead and start doing that particular modeling. So you will get the comparison done. You can see the comparison here. Based on the comparison, you can see that which one is the best, or you want to do a combination of model comparison statistics. It's a pure statistical work. You can do that one and practice it. My aim here is to just to show that all the possibilities of running it. You can also do a stratification on the modeling. Stratification is based on the given variables, which is not currently, we do not have any stratification variables with us, so I'm not doing any sort of stratification models. So you don't need to stratify anything. In this way, what we did is only what we have done as a supervised learning, but based on the continuous data. Our continuous data was the overall brand equity. And we can slightly change the overall brand equity now. And I'm not interested in overall brand equity. Assume that that is also part of my feature. Assume that we have 5 features in our hand. But now this time, I'm interested to classify the customers into a loyal customer and non-loyal customer based on the variable given to me, which is CLC. You can place the CLC in the target variable. Now remember that this is a categorical variable. Whatever things what we are having is always a numerical variables, which is a continuous variable in our case, though it's a Likert scale. Consider to be continuous as of now for this particular problem. Now what happens is the moment you change your classification algorithm, so you will be getting a completely different statistics. You will not be getting the statistics which you are getting before. It's going to be completely changed based on the classification algorithm. You'll be getting what is the area under the curve. You will be getting F1 score, prediction, and recalls, and all the things you'll be getting it, not your regular statistics. Basically, you can get a confusion matrix out of this. I don't need a scatter plot anymore, so I'm removing the scatter plot. You can see the prediction. Now the prediction is in terms of classification because your dependent variable is a categorical variable with ones and zeros. Hence, your SVM, your random forest neural network, it's expected to predict a classification numbers, which was not the case previously. Previously, if you say that your SVM for predicting the overall brand equity, it was predicting continuous variables. If you see that all these predictions are continuous variable prediction for your OBE. Now, because your dependent variable is changed to one classification, so everything is understood and start predicting classification. Not only that one, but also you can see that one, your test statistics, the comparison statistics are different from your regular regression analysis. All the other things hold same. You can see that what is a test on training data. And in this case, training data, it's having 100% prediction power. You can also see that test on the test data. Test data is also predicting very nicely. Sometimes you have to be very careful when we get these kind of numbers. Probably this may be overfitting. So we have to say that which is the best method, whether overfitting is taking place. Then if you make a cross-validation procedure, where segmenting the given data into 5 pieces and keeping one data set, one piece of data set is out for testing. In that case, you can see that there's a variation coming here. You can think of increasing the numbers of cross-validation to higher dimensions. The number of folds could be 10 now rather than 5. It's going to take much longer time than the 5. You because it has to execute every groups one by one or every subsets one by one. And you see that the fitting is taking place, but in my view is kind of an overfitting. And after identifying the test procedure, you may be also interested in using other evaluation procedures. For example, you can work on a confusion matrix, which is a prediction evaluation procedure. You can see that exactly what's happening. So you can send it from test to score. And you can see your confusion matrix. You can see the confusion matrix for SVM. You can see the confusion matrix of a random forest. You can also see the confusion matrix for the neural network. Not only the confusion matrix, the prediction, but also you can think of getting in other informations. You can think of getting a proportions in terms of the percentage, proportions of the actual you can get. Not only a confusion matrix, you can also draw an ROC curve. You want to go for an ROC curve. You can see that all together you can have ROC curve or only for the SVM alone, random forest alone, neural network alone, or all together. You can see that how the ROC curve behaves based on the mean true positive rate. You can construct your curve based on mean true positive and false positive curves. You can make it. You can also look for an individual curves inside. You can also find a convex ROC curve, and also the hull you can identify. These are the various procedures are available. It depends on how you want to explain your given problem in terms of its classification power and justifying through any sort of an evidence from the ROC analysis or a confusion matrix analysis. People also use the lift curve of procedures. You can, based on all the lift curve, you can say that either you can use an ROC curve or you can lift curve, depends on the application or how you want to position your analysis and how you want to defend your case of research. So based on that, you can use some supporting graphs, either ROC or a lift curve, though there are debatable approaches are available, which one is the best to use. But in my view, always that when to use what. It doesn't mean that ROC completely could be ruled out because lift is doing far better. I won't agree on that one most of the time. I always go with a typical application, which one is most suitable, how we can use it. And this also can be done with a particular class of 0 and 1. And also you can think of doing a cumulative gains also. And like this, so we can use plenty of widgets for the classification, but of course for the random forest, but when your Y is continuous data, your target is continuous data, then you are using only kind of regression type at the time only. You can use your test correlation matrix and prediction. All these things are not going to be useful. And note that if you want to delete anything altogether, you can always do a deletion by selecting everything in one go, informing and deleting it. This is one of the simplest formation to go for running an supervised learning based on either a classification data or based on your continuous data. Let's go and see what are the other things are available for us to model it. The most of the time, whatever I have used here, this is more than sufficient to carry forward with the initial algorithm. Then you can use the save data to save your data after your prediction. Let's say that you're predicting and you want to save this data to your data frame, because as of now it is not yet saved. You can always connect to the save data and then you can give your particular file name and then save it. And in that way, it's going to be kind of an easy to keep the record. Otherwise, you're going to lose your record. You can always save in CSV, or if you're using an advanced analysis, something like, you can also save it as an pickle for any other reading. I mean, I'm not going to save this one, so let me remove this one from the model. Well, and there comes the data visualization. You can use many projections here. So let me go for, let me remove all those things. As of now, we covered everything. Let's not keep this one too. The reason behind removing is I'm just giving some kind of more space and not loading the algorithm. So in that way, it's kind of an easy for me to run it quickly. Column is not required. Remove that one also. So, yeah. You can bring the box plot here if we have already done a box plot. Sorry, bar chart, bar plot. Connect the bar plot to the same thing. Data to data, say okay. Then you can see that you can go ahead with your bar plot to do it. One nicety of this particular software is it's so easy to use it. But always remember that when you want to write research papers, you have to be a bit careful on what you're extracting, how you're extracting, and how you're storing. Because most of the time, the results are going to be very quick, and you should not misuse any output and then interpret it in a wrong way that completely ruin your research. And also you can think of using basic projections. You can see that the basic projections can be done here using your principal component analysis. You can easily see the projections, how it's taking place. I can also color it based on my classification, so it's kind of easy to use it. And you can start increasing the number of variables inside. You can see that how the projections are taking and which direction it's going on. The brand association is completely different from, but brand awareness and overall brand equity is having kind of a similar projection. And also brand loyalty and perceived quality also going together in one single direction. You can do many kind of projections here. So this will help you to give an initial shot that how the data is moving. Most of my research, I go ahead with the simple diagrammatic approaches like this, but though I will not, I'm fond of using my Python code or else a Julia code. But for initial guess with a simple small data set, you can always see using this kind of software. But when the data set is, for example, this particular software cannot handle 100,000 data. It immediately, even a 10,000 data set, it is difficult task for to run. But whereas when you happen to have a huge amount of data set, and these kind of softwares are not priced for a production purpose. But for a simple research, you can try and you can get some initial idea of the data set using these kind of softwares. But one of the good software in my view for initial data analytics or a machine learning kind of work. When it comes to the modeling, you can see that there are so many modelings are there available. You can make use of everything, including a neural networks and a tree-based diagrams. So many things. You can bring a tree, and then but for tree again you need an input data set, an output data set from your data point. Select the sampler, and I can use the tree models. You can also use a logistic regression, naive-based regression, and also you can use an Adapt Boost if you want to run the model based on Adapt Boost models. You can use it. One good part is for whenever you place your mouse on the top of the widget, you can always say that what are the inputs and outputs are going on. Accordingly, you can provide the inputs and outputs. Here, if you see this one for the file, you're not having any input bracket. So only for the output. It means that whenever you see something like this, only for that particular output it works. Nothing will send as an input. It means that if you try to send something here, and it will not go. It's not ready to go and connect it. And also see that what all the outputs are available. Probably you can identify from the list here. That's the easiest way to identify. And you can solve the problem. And the evaluation, remember that you have the first one is the test and score. That's what we were evaluating it. Then we can use all the other things like a prediction is the immediate next one which is required to see the data. And then when it comes to a confusion matrix, ROC, lift curve, and calibration plot, all these four are used for classification purpose. So if you're machine learning, supervised machine learning, having a classification type problem, you can always use these four. You can also think of using an unsupervised learning. For example, a hierarchical cluster. Let's see that what happens with our data set, whether a hierarchical cluster makes any sense or not. Again, you need a, actually you don't need a data for, let's see, need a data sampler, select column, go for data to data. And remove this one. No, because of that file only the problem was. We have 5 here. Should be in question 2. It's looking for a distance matrix. You can get the distance matrix, then it should connect. Because the distance matrix is required, which calculates the basic distance based on the cosine or a Spearman. So you can have all the possible distances are available. You can choose also Euclidean distance, Mahalanobis distance. You can use the distance matrix. What are the distance matrix required for your distancing? And then form a hierarchical cluster. Then you can see that the data is forming a hierarchical cluster. In this case, you can see that one. You are having a cluster of 3 sets. C1 is a cluster, C2 and C3 are the clusters. But you can slowly move this line to change your cluster lines. So it depends on your level which you're looking for. And then we can form a cluster formation. This is really useful model because sometimes in a real-time application, once I'm involved in a problem wherein we have to select a particular group of clusters where we want to do a campaign for a particular product, and then we want to see that whether the consumers are interested to convert and then buy that particular product. We were doing a kind of and came in cluster analysis also and hierarchical for some purposes. In such case, we happen to drill down and start optimizing the number of clusters to identify a specific group, because that was in a higher end group we are looking for, and we could manage to get it notable. But of course, I did not use an orange for that one. But still, orange is more powerful for those kind of simple analysis to identify what is the cluster formations are there and which is the best cluster to start with. Of course, once you identify the cluster, again, you can put it on the table. This is one of the nicest way of doing the things. And data to data. what happens here is you can see that when your cluster formations are taking place, so which customer is falling on which cluster, you can see that one. And then you can form a group on whatever the further analysis you want to carry forward, you can carry forward. So this is again one of the unsupervised learning method. You can also think of using an K-means method or principal component or MDS. You can keep proceeding on that one. For time being, I'm not getting into that. Just to give an overall view, this is sufficient, I guess. And then you can also use an image processing, which is not the purpose of this class. You have a plenty of time series data analysis you can perform with this particular software, and also the text analysis. And you can think of doing lots of text mining, and suppose tutor data modeling you can do with this data. And you can also do a profiling of customers based on sentiments. You can use this data. If you're interested on a simple survival analysis, you can do it. And also, you can do lots of network analysis. If you have a data of network, you can do lots of network analysis and so on and so forth. And also the basic association rules you can perform. Now, the idea of this workshop is, once I'm done, because usually that's how we do it, once I've done this particular modeling, I expect this participants to do it. We have about 1 hour. So if you can install this software, first of all, in your laptops and see that whether you can install Orange, you can just download it from the web page. You just look for an Orange, you can download it from the web page. Would you mind installing it and then try this version and then see that whether you can run a one supervised learning? What I'm going to do is I'm going to stay with you for this 1 hour as your practical class, where you can run and you can ask some questions and I'll try to help you to solve it. In that way, you have some sort of an interaction rather than going for a monotonous, almost I'm going monotonous 2 hours of talk. Now I can help you guys to sort it out and then see that how you can solve this problem, simple problems. You can take any of the book problems, or you can just write 1, 2, 3 on your Excel sheet. That's more than sufficient to just see that how the numbers are running and the software. Is that okay? Dr. Faiz?
Hello, sir.
Yeah, can you hear me?
Yes. Yes, I can hear you, sir. So everyone,
Yeah, this is a actual workshop, so we need to see that the participants are practicing it actually. Otherwise, there is no meaning in calling this as a workshop, isn't it?
yes,
So
sir,
my
that's
idea
fine,
is
sir.
to.
But the main thing is that that is fine that all of the participants now please install Orange in your desktop or laptops and try this yourself. Try a data set, and whatever problems you have, you can write in the chat box. So they do not have permission to share their screen or turn on their camera and microphones.
Oh, is it?
Yes, sir.
Okay, so I was under the
So,
impression that
yeah.
it can be completely an interactive workshop so that I can
Right, sir.
interact with them.
Yes, sir.
That's fine,
Yes,
no
sir.
problem. So what we
So,
can do is actually, I'm going to stay here and then I'm going to wait for
okay.
their comments, anything actually that so I can
Okay.
answer and then make sure that they are practicing it and at least do one supervised learning method.
That's fine, sir. One of them is saying that please share the data set as well for practice.
Oh, for this data set, I cannot share it. Actually, it's more of and what you can do is actually I can show you that how to you can create in some sort of a dummy data set and run on it. That's what I can tell you.
Okay. So everyone, please download Orange. You should be working on your laptop or desktops right now. So at least try this. At least create your own data set.
If you want to
Create your
create a
own
one
data
data
set.
set, we can create right away using some Excel. Let's do
Okay.
that one.
Sure, sir. Sure, sir.
Let's do that one with an Excel. Just to give you a second. Actually, let me open an Excel sheet and then
Yeah.
let's try to create some dummy data set for us actually. Can you give me a sharing permission again so that
Oh, okay.
I can share the Excel sheet and we create a dummy data set for this exercise.
So you already are sharing, sir.
Is it? Okay. Can you see my Excel sheet?
Yes, sir.
Okay, let's do some blank data set. Call your variables
Right.
target, then start create a run between, then say 1 to 10 scale some numbers, let it come out. Do it for, let's say, 100 samples. You will not be getting a meaningful result, remember that, because it just we are doing an feature 1, feature 2, feature 3, and feature 4. Go for a run between again, let's say that 1 to 5. And here, run between, say, 6 to 10.
Sir, are you actually typing, sir, right now?
Yes,
Are you creating the data? Okay, it is not visible, so we're only seeing a blank Excel sheet.
is it?
Yes, sir.
It's kind of in here at now.
Now it's fine.
Okay, so what I did
Okay.
was here just place a target here, and then let's call this as a target for this a target, and then let's call this as the next one. Just give an insert command. Just say that again, target, but this time it's a class, right? Okay.
Mhm.
Then I want to give a class as something like if my this one is more than 7, I would like to give 1 as a classification, otherwise 0, something like that. So I'm just, because we want to run a regression as well as we want to run a classification algorithm, so it's better to go for a regression type or else a classification type. So I want to have 2. Then here I'm just randomly selecting the values from 1 to 5, and then here some 1 to 6, and here just I want to play with an given random number times, and say 10 times another rand function, just to happen. Another rand function, something like this. That's sufficient, I guess. So here as your dummy data set, you can create something like this, and then you can feed this number inside. That's it. But if you want the data which I've used, just give me some time. But after the lecture, I can send you the mock data from the data set, because I cannot share the current one, but I can give a mock on that one. So that will be useful. You can use it for later stage.
Sure, sir.
Now, these 3 are your features, and you can do a regression supervised learning with the target, this one. And also you can do a regression with, your classification with the target C. If you want, I can walk you through this data set. Let me store this one on my desktop. Set this data. orange. Is it my orange is visible now? Dr. Voice, can you see my orange?
Yes.
And go for the new one. The new one is visible? I don't think so. We delete everything till here. Then let's do that one from fresh. Save my data in on my desktop. Just pulling my data. So now you can see my data set. So in the data set, you can see the target C, and everything is available. Just connect the data set to an data table. You can see the data table, your target, your variables are given. Now from here, you can start your modeling. Remember that you have to choose your sampler. Before that, if you want to choose a column to see that, select column, go to the data set, select your column, connect the column, double click. I don't want this one because I want to run a supervised regression. Move the target, bring the target to the target box. Once this is done, you can start running your model. You can bring the test score, and also you can bring your model. You can bring your random forest, like the random forest, and your model start running. You can see your results. Dr. Faiz, could you see my results, test scores? Is it visible?
Yes, sir. The mean squared error and
Okay,
the
that's
rest of
fine.
the values are visible. Yeah.
Because sometimes some sort of
Hmm.
sometimes it is
Yes,
not
sir.
visible. I have to share the entire screen. Good that it's
Okay.
visible.
Okay.
And once this is done, you can go for your prediction. You can see you are already predicting your variable. You can see that this is your regression random forest prediction. This is your target. Both can be done. But remember that you did not bring the sampler. It's always good to split the data to model it. You can go and bring your sampler, then just insert between these two. That's it. Once the insertion is done, you can choose what are the percentage you're looking for. 70%. But remember that still it is not done. You need to double click here. You have to send 70% of data to the data, and then remaining data to the test data. Then only it works. What is done? You're done with your model. Now it works with your training data. Test on your training data. Test on your test data. Remember that in our regular method, we don't get R square negative. R square is always positive, but in machine learning, this is always possible because of the model. So you have to always tune the hyperparameter. Timing it's not required, just we are learning the regression part. In a later stage, you can learn that how we can do it. Also, you can do your task validation, go for fivefold. you can run your model on a cross-validation. Remember that when you're doing cross-validation, there is no meaning of doing a test and train data. It is different from, or either you split the data into two pieces and do it, or you can do the cross-validation, splitting the data into few pieces, and then take one piece one after one to model it. This is at the level of random forest, but still you can go back here. To the table, sorry, to the column table. You can change the target variable to be a classifier, which has a C inside. Once your classifier is changed, then it works as a classification algorithm inside the same random forest. But you can see that your performance metrics changed already, right? Because it's a classifier, the metrics is changing. Because of it's a classifier, you can start using other evaluation procedures. So other evaluation methods where you can bring your confusion matrix to see what happens. You can bring your ROC to what happens. And also you can bring your lift curve to. Procedure wise, it's rather simple. No need to worry at all. Within no time, you can drag the things and see that one. But in the real-time application, you have to be very careful that how you are doing these things, which is a big story of teaching the entire machine learning and how to make use of every statistics inside. So I leave with your participants, and I'm going to be here. If you have any doubt and clarification, I'm happy to answer it.
So those of the participants that have a good internet connection can download it right now. Please do so and try this problem yourself. The file size is a bit large, but those of you who can do it, please do it right now. And then if you want, you can share your screen also to ask any question to have a solution to your problem. Or you can just ask your questions right now in the chat box. Sir is here, so anybody who wants to ask anything? Sir, the questions they are asking me, I'll forward them to you.
Yeah, sure. So where I have to see?
In the chat box, sir.
In the chat box. Yes.
Let me copy it.
Okay, please, can you do one more time?
Yes,
Of
sir.
course. I can show you that one more time. Now again, I'm removing everything. Okay, if you're starting from clean box. Here I'm selecting my data. My data is available on my desktop. Selected the data. So data has three features, two targets. I specifically designed two targets because one is for the continuous variable, the other one is for the categorical variables. For the categorical variable, I placed 0 and 1. Some classification. You can have more than two classification. And once this is done, my data is available. I wish to see the data. If you want to wish to see the data, then use the data table. You can connect the data file to a data table. This will allow me to see the data. And I can also understand that I have 100 samples, 100 instances. totally 5 features. It means that, see, the system is going to assume whatever I'm giving inside as a features. It's not going to understand it's a target. It's only me which I'm going to tell them that whether it's a target or not. In which format the file will be saved. You can save the format of CSV. Also, you can use pickle and other formats are available. Use the save file command here, which is available here. And then you can see that what are the formats are available for save as the file. Is it okay? Fine. So once this is done, and I'm interested to start the modeling, but here everything is, as I stated, that everything is considered as a features, and I have to inform the system that which is a feature, which are the features, and which is a target. To do that one, I have to go and select the select column. Once the select column is given, then I can connect it. Remember that again, you always need to go for the data to data. You're not selecting a specific data to do with the model. And then here, I am only interested to go for first regression type supervised learning. So I'm saying that 3 features and 1 target. Once that is done, if you're interested right away, because you know that you have to split the data, you cannot do the data with the full modeling. So I can bring the data sampler right away. I can connect the data sampler. Here I can choose, let's say, this time 82, 20. Once this is done, then go ahead connecting this one to one test score. But remember that this is not done, because you have to tell here very clearly 80% data should go to the data and the remaining data should go to the test data. You have to do this one whenever the sampler is coming inside. This is done. It's a two-way connection. All the other things are single-way connection. Here you need to do a two-way connection. As of now, this is done, but we did not declare the learning algorithm. Go to the model. Maybe your first learning algorithm could be a random forest. Bring the random forest here, then just connect it. Once the connection is done, automatically it starts running. Then you can see the results. We can see the results in 2 ways. One is test on the training data, which shows the 77% explanatory power, and then test on test data, just showing 32% of explanatory power. Once this is done, you can have 2 things here. One is seeing the prediction. You can see that whether how your data is getting predicted. This is your original target. This is random forest predicted target. You can see that because this is just a random approach. The data, what I'm selecting is just a random approach. There's no model exists, just for modeling purposes. I did that one. You can see what's happening here. Now, also, you can have a graphical feature where we are looking for a scatter plot. Where in the scatter plot, you can see that your target versus your random forest prediction. This is what it is. This modeling is only for the regression type. If you want to increase the number of learning algorithm to see that how other things are performing, you can also bring SVM and you can also connect it. At the time you can see that 2 models are performing, and you can see that still random forest is outperforming when compared to support vector machine. This is at the level of regression type models. Let's assume that I can do that. The model again, I can go for a data table. This parallelly I can do that one. And this time also I'm selecting the select column. But this time my target is C, not the target. Because I'm doing a classifier. Here I did a target variable, and this time I'm trying to do a classification variable. Remember that here I want to send always data to data. remove this one. That's fine. Now this is done. Same story goes here also. You can use a data sampler. Using a data sampler, again, you are interested on 70%. That is fine. From here, again, you are expected to go for test scores. Take this test score. And in this case also, what we are interested on is the test score. But here, again, you have to do the same procedure. 70% of data goes to data modeling, remaining data for the test. Both times it's done. Now, again, I'm going to choose a random forest. I'm going to connect that one. But this time, remember that my dependent variable is a classifier. Because of that, I'll be having a classifier-oriented statistics. We can say that recall precision and all the things are available. Area under the curve. For this, again, I can use the prediction to see that one, how it's getting predicted. So I can use the prediction. Now you can see that my target C and also random forest predictions. And because it's a prediction problem, we have varieties of other tools are available to check the performance of the model. One is a confusion matrix, which you have studied in your statistics course on discriminant analysis. One of the discriminant analysis, the best way we showed to the students using a confusion matrix. We can use the confusion matrix to show that one, but also ROC is one of the fantastic way of showing them. We can use an ROC curve to do that one. We can show all the possibilities you can try. And also you can use the lift curve. That's going to be, again, you can use the lift curve, and also you can use your calibration plot. So these are all the possible things you can use it for your model. Because all these things are coming because your data is your target is a classifier. If it's a regression, you can only go for a prediction and plotting the score. This is what you're doing, both things. Does that make sense? You can also do with this one, let's say that if you are interested to do the modeling on, again, select column. But this time you are only interested to do the model with altogether. You can bring your distance matrix here. And then you can choose like a cosine, let it be cosine. And then you can bring your hierarchical cluster. And you can see the cluster analysis done in the same place. But usually I never like to populate everything in a one sheet, but just for understanding purpose, I'm showing everything in one sheet. Otherwise, it's better idea to go for multiple sheets to work on, because otherwise it suffers, the system suffers a lot and it won't work most of the time. So in one go, you can see that we did a supervised learning with the regression type where your dependent variable is continuous. And this set we have done supervised learning, but here the dependent variable is categorical. And also we can do an unsupervised learning like an hierarchical clustering. It's rather simple. Is that okay? I hope I explained once again completely.
So sir has explained that once again. I hope that it is clear now to everyone. Can we have any more questions from the participants? One of them is asking, how are we to interpret the information and the graphs?
Okay, that's a good question actually. That I'll leave it to you guys actually, that I can send some of my research paper where you can interpret and see that how the interpretations are taking place.
Yes, sir.
When it comes to an ROC curve analysis, in the center diagonal line, anything is below this line, the model is not at all performing well. If it's falling on this line, then you can say that the model is performing exactly at the random fashion because it's a 50-50 percentage. Anything above this line, if your model is performing, then you say that yes, it's doing well. But ROC analysis is not good for just a single model performance. If you're interested to do on multiple models, then we can say that when the model is going to be all right. For example, suppose if you bring in SVM, it means that two models is entering inside. Then both the model arrives, then you can see that one. Two models, one is a random forest model, and then the other one is an SVM model. Now let's go and see that one. First of all, our test score. You can see that in our test score, SVM is performing very well, okay, which is covering 75% of the area under the curve. Once it started covering a 75%, it's far better. That's what you can see here. Your SVM, which is an orange line, which is covering the higher area when compared to random forest. In this case, we say that, no, that's better to go for an SVM because SVM is doing better. Because this is not only the case, because in real life, we have a multiple application procedures are available. How much risk we are taking on the decision, which is usually we teach in statistics and a type 1 error, type 2 error kind of things actually. So which one we are looking for, which one we want to improve it purely depends on the real-time application. We try to play around this curve and see that which one is the best one rather than very blankly showing for a highest possible area covered under the curve, which is very similar application we can think of and discussing in terms of the lift curve and other things. The other way around is to showing the same information in terms of the confusion matrix. In the diagonal values of this confusion matrix, we say that it's correctly classified. And then the non-diagonal is misclassified. And then we say that what is a misclassified percentage. Then we discuss on how to go about it. Okay, here's a question. Notice that IBM wants to do the same thing. Yes, of course. Actually, there are so many other softwares that are available to do it. Actually, you can do it with IBM Watson. You can do it with many other softwares are available. Nine is available. You can use in Nine. You can do it. You can do it Orange. There are plenty now. So many things are there, and you can do with Vika. Many things are available. The idea is use any one of the software just to get an initial practice, and then my advice is directly jump into Python or Julia, start coding it, and then you will get a more robust way of solving the problems and seeing the results. This should be just an initial stage to understand the problem or understand the model. But if you're not a non-programmer, if you're not interested to program, then these kind of softwares are really a great gift where you don't need to use any programming knowledge to solve the problem. Or you can also integrate your programming knowledge within this kind of software using your Python scripts inside. And I'm sure
Any
that
other
in
question?
just
Yes,
3 hours, it is very hard to cover everything inside. But what all our idea is to just to throw some lights, because you're all faculty members. Once you get in some small glimpse of what is happening, you can read yourself and you can pick it up very quickly. So that's the idea. That's why I did not bring a kind of a student way of teaching it. I just brought it like a faculty members. and your learning is different from the student level of learning. So just throwing some lights on you is more than sufficient to pick it up and then start doing yourself. However, if you have any doubt, you can always feel free to send a mail or something like that after the class. I'm happy to answer. Probably in the weekends, I can answer the questions.
Any other question anyone wants to ask? Please go ahead and type.
You can see my slide?
Yes, sir.
Yes. So those who are researchers, if you are interested to submit the papers, feel free to submit the papers to these journal, but they are tough to publish. It's not easy to publish. Okay, it is tough. But if you are in the field and you want to really wants to do something on then you can count on these journals. And they're having an highest impact factor. The first two is having an highest impact factor. All are Elsevier, but the first two is having a highest impact factor. So publication is very difficult. And the other one is it is also publication is difficult, but it's doable. And other two journals, but the first two is much more tough. And also you can think of, if you are working on a business oriented side, you can think of publishing it, or at least to start reading the papers from these journals. You will get some sort of an idea that what all the papers are published in machine learning and intelligent system and expert systems. If that is your field, or if your field is statistics but still you want to jump inside, you can always go for that one, because I started my career as a statistician and then move on to the ladder in a different style.
Please thank Professor Charles. You
Thank
can
you very
directly
much.
message him. Everyone, please thank him.